Hey, what's up, class? I hope you're all doing well and you enjoyed your spring break. Just want to let you know that I miss you all, and I wish we were back in the classroom getting our learning on. But we're not, and we're going to continue on with online studying. So I'm going to do my best to give you as much information as I can throughout the week and make you the best learners that you possibly can. Today, we're going to review the 3 investigations about mirrors, spectra, and color before we get into part 4. An electromagnetic wave is defined as a wave of electricity and magnetism that can travel through a medium or empty space. Light is electromagnetic radiation that travels as electromagnetic waves. Going back to weather and water, we learned that light travels in straight lines, cold rays. A laser travels in a straight line, cold ray. On day 6, we looked at the Mirrors Laser Lab. In that lab, we used lasers and mirrors to explore properties of light reflection. We measured the incident and reflected angles using a protractor and concluded that the beam of incidence is equal or very close to equal that of the beam of reflection. On day 11, we discussed spectra, and you look through a spectroscope when you view the online lab to analyze spectra from various light sources. Spectroscopes reveal that white light is composed of many colors, each of which has a distinct wavelength. When we read about the electromagnetic spectrum, which is a range of all different electromagnetic wavelengths, including visible light, which is measured in nanometers, that can be seen as different colors, and other wavelengths that cannot be seen by the human eye, such as radio waves, X-rays, infrared, ultraviolet, microwave, and gamma rays. On the last lab that we had on day 19, you viewed an online simulation using filters. In the simulation, the color being emitted from the flashlight is white, but the color is made up of a spectra of colors. You get your Roy G. Biv, your red, orange, yellow, green, blue, indigo, violet, but we still see that light leaving the flashlight as white light. In the second part of that lab, you use the filter. A filter is just a transparent material that can absorb certain colors to see how different wavelengths of light are perceived. And that's color. This brings us to day 21, refraction. That's your lab for today. It's the 4th part in the Make Waves investigation. We're going to see how light rays may bend as they move between media. Here, I have a 120 millimeter diameter acrylic refraction cell. It has a semicircle shape and it's filled with water. As you notice, it's resting on top of a protractor, the same protractor sheet we saw in the Mirrors lab. Today, we're going to be doing 2 setups. The first setup, the incoming laser beam, which will be projected towards the flat side of the semicircle, and then setup 2, where the laser beam will be projected towards the convex or curved side of the semicircle. At this time, you'll be referring to the Refraction Test document so you could record your results. As I shine the laser towards the normal line at 0 degrees, at the reflected side of the protractor, what number does the laser beam go to? When I shine the laser from 10 degrees, what is the angle of refraction? So 10 degrees, my laser light is on, and the angle of refraction is also 10 degrees. So the difference means to subtract, so 10 minus 10 is 0, and I'm gonna put that in the second box to the right. Now you're gonna stay on the grid on the left-hand side, because we're gonna do step 1, and then when we do 10 degrees all the way to 80 degrees, we're gonna go to step 2, and then we're gonna repeat the process, but we are going to use it on the flip side of the convex or curved semicircle dish. So once I have my laser on 20 degrees, what is my angle of incidence? Well, you know your angle of incidence because it's on 20 degrees. We're looking for the angle of refraction. So what is the angle of refraction? Once you see that, record that on your refraction test, and what is the difference between the angle of incidence and the angle of refraction. Next, you're going to do the angle of incidence for 30 degrees, and then record your results for the angle of refraction, and then come up with the difference. Next is going to be 40 degrees. which is your angle of incidence. That's where I'm starting my laser. What is the angle of refraction? And record your data. Next is 50 degrees. 50 degrees, what is the angle of refraction that you see? Record that data. 60 degrees is my angle of incidence. That's where the incoming laser light is coming from. And the angle of refraction, where it's coming out of. And record your data. Next, you have 70 degrees. 70 degrees, follow that laser light. Where is that angle of refraction going? Record your data. Finally, you have 80 degrees. Where is your angle of refraction? And record your data. Now that you have all the data for that, now you could take your difference. So you're gonna subtract. So again, the first one, you had 10 degrees, which is my angle of incidence, minus 10 degrees, which is my angle of refraction. So the difference would be 0. And then you would do that from 10 degrees to 80 degrees. Now I'm gonna show you step 2. Step 2, I'm taking this semicircle disc and I'm turning it around, and I'm gonna be shining the laser light through the convex side of the semicircle dish. You're gonna follow the same steps, but note at the bottom of the graph, it says at what angle in which step is there no longer a refracted beam. So you might not be seeing a refracted beam in the lab. So again, I'll take you through each step. We're starting at 10. Now we're underneath step 2. So 10 degrees is my angle of incidence. What is the angle of refraction? Record your data. And then do the difference at the end once you have all 10 degrees through 80 degrees. Next, you have 20 degrees, which is my angle of incidence. What is the angle of refraction? Next, my angle of incidence is 30 degrees. Record your angle of refraction. Now you have 40 degrees and record your angle of refraction. You have 50 degrees, which is my angle of incidence. And by looking at the screen, record your angle of refraction. 60 degrees. Record your angle of refraction on your refraction test. Next, you have 70 degrees. You should be recording your angle of refraction as the laser light goes through the semicircle dish. And then finally, you have 80 degrees, which is my angle of incidence. My angle of incidence is 80 degrees. And what is the angle of refraction? Again, that note says on the bottom of the graph, at what angle in which setup is there no longer a refracted beam? A refracted beam, if it's not going through the semicircle dish onto the other side of the protractor, you're going to write NA, not available. Now go back, record the differences between each. So again, 10 minus your refracted beam, your angle of refraction, you're going to come up with a difference and record that on the top right box. Once you're done with that, answer setup number 1 and setup number 2 questions underneath conclusions. If you have any questions, please email me through Canvas. I'm pretty much always available. Stay safe, wash your hands, be good. Peace out.